listen, good morning. Okay, recording started. So the other two videos have been posted. If you're interested, I put them in the news item beside the information. So if you're saying I want to see that again because it was the most exciting thing I've ever seen in my life, that's where you'll find it. So right on the main page of the course in the news item. Okay? So today, as promised, I'm going to describe the physics of steps, complete equations, algebraically isolate, substitution with units, final statement of prediction. That's what I'm going to go over. Okay, and that shouldn't take long. I'm going to do one of the intervals. And I've chosen interval C because of the three intervals, I think it is the most interesting interval. Okay? So, describe physics of steps. This is boilerplate. What do we mean by boilerplate? When you go to a lawyer, there's stuff that's already written and they just copy and paste it all the time in wills and things like that. So what am I looking for? Here's what I'm looking for. We want, so in part C, we want what? The displacement over interval 3 to 4. And see, when you name intervals properly, right, it makes it real easy to communicate. We know, what do we know? We know V2, V3, which is equal to V2. V3, what else do we know? We know V4 and A 3, 4. So we can use, and here's where you go and find your equation. So what do we know? We know the final velocity and the initial velocity and the acceleration, and we want the displacement. So which equation would we use? I'm thinking it's this one here, right? Final, initial, acceleration, and displacement. Right? What do we not have? We have 5 kinematic quantities. What are we missing? We're missing the time. So you can't use anything with time in it. That might be the easier way to choose your equation. I say, okay, this one doesn't have time in it. And how do I know this is going to work? Well, because I have 3 known things and 1 thing I'm looking for. Remember the statement, right? If you know 3, you can find the 4th using the big 5. Okay, so we can use V4 squared equals V3 squared plus, and I'm just going to look at it to make sure I don't mess it up, 2A, and if I really want to be clear, this is A34 delta D34. Except we're not going to call it delta D, we're going to call it delta X to match our coordinate system that we chose. 3, 4. Make some sense? Why can we use this? There's one piece missing. Since, so we can use this equation since we are assuming constant acceleration. Or if I had asked you for average acceleration, you would say because we're only interested in average acceleration. Remember, if the acceleration is changing, we can't use big 5 equations. So, complete equation. Look, I wrote it down here already. Okay? Algebraically isolate. What am I trying to find? Delta x34. So delta x34 is equal to. Now, the algebra steps here are, and I'm not going to write them out because I don't expect to see them. My hope is that you can do these quickly. If you need extra help with this, I have some packages. I've offered them. If you didn't get one and you want one, just ask me for it again. So we need to do bed mass backwards. So it's going to be V4 squared minus V3 squared. And it's important to put them in the right order. All divided by 2 times A3, 4. So that's what I mean by algebraically isolate. Okay, and that's just math. And like I said, there are actually some extra help available at lunch for people who need help with this kind of stuff specifically, and I would need to recommend you for it, but Mr. Hodgins, I think that's his name, helps with that, and he's a math science guy. So, also, okay, so, and I kind of say at this point, I'm just going to go right ahead and substitute with units. So what's V4? V4 is 0 meters per second. So substitute with units. Minus, what's V3? V3 was the same as V2, which was 238.5 meters per second, I believe. 282.5? Thank you. Okay, you can go, you have this written down somewhere. Squared. And remember, this is a positive velocity. You're not going to put the brackets around the negative. You're not going to square the negative. And what are we dividing by? 2 times the acceleration, which is minus, and I need to look that up. So it is on my list over here, 445 meters per second squared. How do I know that my acceleration must be negative here? The velocity was positive and it's slowing down. Okay? So I know that needs to be a negative. And if you do the analysis, you're going to end up with a negative here and a negative there, so your final result will be positive, which is what we want, because he was still moving forward. Okay, key idea. Now the next part is, do you know how to use your calculator? And some people run into trouble because they don't. And particularly when they deal with division. So division looks, whatever's in your denominator, always put in brackets when you do this kind of calculation. Unless you have one of those fancy calculators that shows you all the fraction, okay? Then you're okay. So how would I enter this? Well, I'm going to go, and you have 2 negative keys, by the way, often, not always. This is the one you use for negative values. Okay? Not this one. Okay, so what are we doing? 200 minus, actually, you know what? I'm just going to look at it and I'm going to say, I know it's going to come out positive, because I'm going to end up with a negative on top and a negative on the bottom. Since I know they're going to go away, I'm going to use my brain, and I'm just going to leave them out. Right? Makes it less likely to make a mistake. Right? A negative divided by a negative gives a positive. Right. These are rules that you just need to remember at this point. Okay, it's not necessarily intuitive. So 82.5 squared. We're squared on this calculator. This is why it's nice to have a calculator you use all the time. Divided by 2 times 445. Does that make sense? And that equals 89.6699. So I'm going to write it right here. 89.6699. I'm going to stop there. Why? Because I only really want to keep 5, right? I guess someone can't read unless someone erased what's on the door. Now let's analyze our units here for a moment. This is going to be meters squared per second squared divided by meters per second squared. What are we going to be left with? Meters, right? Meters squared over meters gives me meters, and second squared over second squared gives me 1. Okay? We good? Okay, then. So did I describe the physics of the steps? Yes, I cross it out. So this way you don't forget things. So when I'm done, I always go back and I look at my list and I say, what, did I write complete equations? Yeah, that was right here. There's my complete equation. Did I algebraically isolate? Yes, I did. Did I substitute with units? Yes, I did. Is there a final statement of prediction? No. So this is an English language statement. So kernel step. And the other thing I'm going to put here is a plus in front, because that's going to remind me that this is a vector quantity. When I say displacement, displacement is different from distance. Displacement means the distance between two positions, but including the direction. And in this case, the direction was positive, forward. So there's another way to write this. I'm going to write it the other way in my final statement. Colonel Staps had a displacement of, let's go back to my coordinates as well. I'm going to write it down. 4 significant digits, 89.669. We need to round to 4. Because, why is it 4? It's because I've asked for 4 every time. And now I'm going to refer to my coordinate system. There's 2 ways of showing a direction. One is to put the plus here. The other one is to, I called that plus direction. What did I call it? I called it forward. So I'm just going to put forward. So you use one or the other. You don't use both. Don't put a plus here. Okay? And that is a perfectly good answer. You could also just write plus 89.67 meters. That would be acceptable as well. Are we good with that? And I basically just restated what was being asked for. And I think that's all I said I would do today. So the last piece is going to be evaluation. And I'm going to do that tomorrow. It's like, how do you know this is reasonable? Right? And I'm looking for some connections. I'm looking for you to have made some connections there. Okay? I'm looking for you to, have maybe compared to estimates or things like that as well. Does anyone need any clarification on anything I talked about? You're feeling good about it?
I think so.
Yeah? That's why you're smiling? You say, I'm not smiling, Mr. Bergeron. You're imagining things. It's easier. With students wearing masks, I can pretend they're smiling all the time. So, all good, Danny? Okay, algebra. If you're having trouble with algebra, talk to me. I do have links at the website to some good videos. I find the British do a better job than the Americans or Canadians with that. That's so they're British algebra questions, algebra packages. Okay?